What if time itself had a beginning? What if there was a moment when the word before had no meaning? In 1927, Belgian physicist Georges Lemaitre theoretically demonstrated an expanding universe from general relativity. Using observational data available at the time, he pioneered estimates of the relationship between velocity and distance. Later, he proposed the origin of the universe as a, quote, primeval atom, suggesting the beginning of time itself. But here's where a profound question emerges. What existed before the Big Bang? Can the concept of before even hold meaning? Today, let's venture into the most fundamental mystery, the origin of the universe. By the time you finish this video, the very meaning of time will have shifted. Chapter 1. The Mystery of Time's Beginning. The idea that time has a beginning defies intuition. We've imagined time as an eternal river, flowing without end. But what if time itself was born alongside the universe? What Einstein's general relativity revealed is that time and space are not separate entities. They are woven together as a single fabric, space-time, and matter and energy warp this space-time. This is not a metaphor. This is physics. In 1929, decisive evidence emerged. Edwin Hubble's work measuring distances connected with the redshift observations accumulated by Vesto Slipher and others. The farther the galaxy, the faster it recedes. This means the universe is expanding. And here's where a crucial question arises. If the universe is expanding, then going backward in time, everything approaches an extremely hot, dense state. Extrapolating classical theory suggests singularity-like behavior. Yet that realm requires quantum gravity. Whether an actual point existed remains unresolved. This is where physics meets philosophy. In fact, an unresolved problem has emerged: Hubble tension, conflicting measurements of cosmic expansion rate depending on observation method. Values estimated from early universe CMB give roughly 67 kilometers per second, while nearby universe distance measurements yield about 73 kilometers per second /MPC. This tension may hold clues to updating our understanding of the early universe. So how are scientists attempting to answer this mystery? Let's explore. Chapter 2. A Universe Born from the Quantum Sea. Big Bang Theory describes the beginning of the universe, but it doesn't explain why the Big Bang occurred. From here, the story takes an unexpected turn. What quantum mechanics teaches us is that nothing is not stable. Even in vacuum, particles are constantly appearing and disappearing. We call this quantum fluctuation. In quantum fields, even vacuum can have fluctuations. However, this doesn't mean energy conservation is generally violated. Nothing is fundamentally different from classical emptiness. In 1981, Alan Guth, Katsuhiko Sato, and others proposed a remarkable theory: inflationary theory. Quantum fluctuations arising during the initial rapid expansion were stretched, becoming the seeds of later temperature fluctuations in cosmic microwave background radiation and galaxy distribution. And in some quantum cosmologies, the possibility is discussed that the universe began from vacuum states or quantum states different from classical emptiness. However, creation from philosophical nothingness is not an established conclusion. The Planck satellite released a high-precision map in 2013, and after subsequent analysis, finalized cosmological parameter constraints as Planck 2018 results. It recorded the universe's first cry in exquisite detail. CMB temperature fluctuations precisely constrain the statistical properties of initial fluctuations, interpreted as consistent with inflationary models including quantum origin fluctuations. Consider this for a moment. Gravity's negative energy can offset matter's positive energy, suggesting the universe could arise from nothing without contradicting physical laws. In an expanding universe, total cosmic energy sometimes cannot be treated simply as a conserved quantity. In other words, the question before the Big Bang is difficult to define physically when assuming classical general relativity. Meanwhile, quantum cosmologies like bounce universe models hypothesize a previous stage are also being researched. The answer changes depending on which theoretical framework you adopt. But the story doesn't end here. There's another possibility. Furthermore, since 2023, The James Webb Space Telescope has discovered massive galaxies immediately after the Big Bang that exceed theoretical predictions, deepening the mystery of origins. While conventional models aren't wrong, the discovery that early growth rates were faster than expected has shaken the scientific community. So let's examine the idea of eternally repeating time. Chapter 3. The Endless Circle of the Cosmos. What if the Big Bang wasn't the only beginning? What if the universe has been reborn eternally? This is where science, philosophy, and theology intersect. Some physicists believe the universe is cyclic. After the Big Bang, the universe expands, eventually contracts, and another Big Bang occurs. This is called the cyclic universe model. This idea resembles ancient Indian cosmology, an eternal cycle of creation and destruction. In 2010, Nobel Prize physicist Roger Penrose systematized an even bolder theory in his book, Cycles of Time, Conformal Cyclic Cosmology, CCC. In his theory, after the universe reaches heat death, space-time structure transforms, triggering a new Big Bang. However, CCC is a proposed model, and observational verification remains under debate. And here's where a crucial question emerges. If the cyclic universe model is correct, viewing cosmic history not as beginning and end, but as continuous cycles, becomes possible. The very concept of origin transforms. No beginning, no end. Only eternal change. This challenges Western philosophy's notion of first cause. Is God necessary? Or is the universe self-contained? And here we arrive at the deepest question of all. Why is there something rather than nothing? This ultimate question posed by Leibniz, science still has no answer. Quantum fluctuations, cyclic universes, neither addresses why. Think about this for a moment. By exploring the universe's origin, we're actually questioning the meaning of our own existence. We are the universe's way of knowing itself. Through our questioning, the universe attempts to understand itself. Could there be a more beautiful, humble role than this? So what has emerged from this exploration? Let's synthesize. Chapter 4. The World Revealed. Now, today, we have explored before the Big Bang, the most profound mystery of all. We've examined time's beginning, creation from the quantum sea, and the possibility of eternal cycles. Each illuminates a different facet of reality. Let me share the insights gained from today's exploration. First, time is part of the universe and likely began with the Big Bang. Assuming classical theory, the question before the Big Bang is physically difficult to define, though quantum cosmologies like bounce universe models research hypotheses of a previous stage. The answer changes depending on which theoretical framework you adopt. Second, in quantum fields, vacuum can have fluctuations, but this doesn't mean energy conservation is generally violated. Gravity's negative energy can offset matter's positive energy, suggesting the universe could begin without contradicting physical laws. Nothing is fundamentally different from classical emptiness. Third, science still has no answer to why is there something rather than nothing. This is where physics, philosophy, and theology intersect. Continuing to question with humility is essential. These three insights question the very meaning of our existence. Are we products of chance or necessity? The answer remains elusive. To question before the Big Bang is to question the essence of time and existence. Science offers stunning answers while simultaneously generating new mysteries. Quantum fluctuations, cyclic universes, and multiverses all transcend our imagination. And what's most beautiful is this fact. Through our questioning, the universe attempts to understand itself. We are part of the universe's self-awareness. This fills me with profound awe. So I ask you, if the universe arose from quantum fluctuations, does our existence have meaning? And if time is circular, we've existed in both past and future. How does this reconcile with free will? These questions have no simple answers. Yet continuing to ask propels us forward. The mystery deepens, but so does understanding. After watching this video, when you return to daily life, I want you to be aware of something. When you look up at the night sky, the stars you see have journeyed 13.8 billion years since the Big Bang to be here now. and you yourself are a child of the stars. The atoms composing your body were once forged inside stars. To question the universe's origin is to question your own origin, because we are the universe's way of knowing itself. Share your insights in the comments. Your questions become the force that propels this channel forward. I'm grateful you've joined me on this intellectual journey to the end. On this channel, we explore the universe, consciousness, and the nature of existence from both scientific and philosophical perspectives. If you want to transform how you see the world, please subscribe. Next time, I have questions prepared that will shake your perception. I'd also appreciate your likes and comments. Until next time,